sorry topic of today lecture is ultrasonics, its production and applications. So, first we will take the outlines of my talk. First one is the introduction of ultrasonic waves. Next we will discuss what are the different properties of ultrasonic waves, like what is its frequency, and in the next few slides I will show that how it can be produced by different methods like magnetostrictions and piezoelectric method. Next we will discuss what are the applications of ultrasonic waves, and in the last we will discuss the work problem regarding the ultrasonic waves and its formulas. So, first we will discuss what is sound. So, we know that sound waves, they are mechanical waves, mechanical and compression waves which are longitudinal in nature, meaning that the particle they vibrate parallel to the direction of wave velocity. So, sound waves, and there are two types of waves like light waves and sound waves. Sound waves are longitudinal in nature, but the light waves they are transverse in nature because their particle vibrate parallel to the direction of wave velocity. So, this is the definition of longitudinal in nature. Sound waves they are divided into three categories depending upon different frequency range. So, in the next slide I will discuss what are different frequency range and how we can categorize the sound waves. So, first range is audible waves. The first division of sound waves is audible waves. They are within the range of sensitivity of human ear. The range of human hearing stretches from 20 to 20,000 Hz. They can be generated in a variety of ways, such as by a musical instrument, human voice or loudspeakers. So, the first type is audible waves. Its frequency is within 20 to 20,000 Hz. If the sound wave frequency lies within this range, so we can easily hear this type of sound between 20 to 20,000 Hz. So, they can easily produce, like we are producing, I am also producing a voice which is within the 20 and 20,000 Hz. So, these type of waves are called audible waves. So, next type is below 20 and above 20,000. Then the second type is infrasonic waves. If the waves having frequency less than the audible range, like if the frequency is less than 20 Hz, then these type of waves they are called infrasonic waves. Elephants can use infrasonic waves to communicate with each other even when they are separated by many kilometers, because its frequency is less, so wavelength is more. So, elephants can use these infrasonic waves whose frequency is less than 20 Hz to communicate with each other even when they are separated by many kilometers. So, the last division is ultrasonic waves, and which is the main topic of my lecture. If the sound waves having frequency greater than 20,000 Hz, they are above the audible range and they are called ultrasonic waves. If the frequency of a wave is greater than 20,000 Hz and it is greater than audible range, which is up to 20,000 Hz, so these type of waves they are called ultrasonic waves. Many animals can emit these type of sounds, like bats. They emit and hear ultrasonic waves which they are used for locating prey and for navigating. So, different type of animal use infrasonic and ultrasonic but human beings are able to hear only the audible range. So, depending upon the different frequencies, we can have three divisions. First one is audible range between 20 to 20,000 hertz. Second one is infrasonic, between, if the frequency is less than 20 hertz, then that is called infrasonic, and if the frequency is greater than 20,000 hertz, then this is called ultrasonic waves. So, this is simply the repetition what we did, different characteristics of sound frequency. So, first we will define what is frequency, and this is very important concept. Frequency is denoted by F. It is the number of times the wave oscillates through a cycle each second, and its unit is hertz or cycles per second. If the frequency of a wave is less than 20 hertz, then this is called infrasound, but if it is between 20 and 20,000 hertz, then it is in the audible range. If it is more than 20,000 hertz, then it is called ultrasound. So, for the medical purpose, they typically 2 to 10 megahertz with specified ultrasound applications up to 50 megahertz. So, ultrasound waves starting from greater than 20 kilohertz, they can go up to 50 megahertz depending upon the requirement of that instrument or medical. Next definition is time period. It is noted by capital T or tau. It is the time duration of one wave cycle, and it is reciprocal of frequency. So, time taken to complete one whole cycle, that is called frequency, and that is called time period. Time period is reciprocal of frequency. So, next is introduction to ultrasonic waves. The word ultrasonic, it combines from the Latin roots like ultra means beyond, and sonic means sound. So, ultra means beyond sound. So, beyond the audible range, that is called ultrasonic waves. The sound waves having frequency above the audible range, that is above 20,000 hertz, they are called ultrasonic waves. Generally, these waves are called as high frequency waves because its frequency is more than in infrasonic or the audible range. The field of ultrasonic have applications in many type of like imaging, detection, navigation, medical, etc. The broad sectors of society that regularly apply ultrasonic technology, they are the medical community like industry, military and private citizens. So, ultrasonic waves have many applications depending upon its frequency. Next is echolocation, which is used by bats to detect to navigate and to find food. Echolocation is the use of the reflected sound waves to determine distance or to locate object. Animals like bats, dolphins, they use echolocations to navigate and to find the food. Like here we have shown one example. So, it transmits in ultrasonic waves and they are reflected back by striking with this object. So, depending upon the time taken from here and back to this point, so depending upon this they can easily find what is the distance between these two objects. So, bats use ultrasound waves with frequency up to 0.1 megahertz to move around and hunt. As bats fly, they send out short pulses of ultrasound waves, about 200 pulses per second. So these ultrasound waves, they reflected off from the object and return to the bat's ear. The time it takes for the sound to return to the bat lets the bat know how far away the object is. Depending upon the time taken of this reflected sound from here, from the bat and back to the, from the object to the bat. So this total time from A to B and B to A, from this time they can easily calculate how much distance between these two objects. So next is the properties of ultrasonic waves. We know the frequency of ultrasonic waves is very high. So since the energy is directly proportional to frequency, if frequency is more, then energy is also more. So ultrasonic waves they have a high energy content because of its frequency. Just like ordinary sound waves, ultrasonic waves, they can easily get refracted and absorbed. So they are similar to the sound waves, except the only difference between the sound waves and ultrasonic waves is that ultrasonic waves have more frequency as compared to sound waves. They can be transmitted over large distance with no appreciable loss of energy. So the absorption is less as compared to the reflection and refraction. If an arrangement is made to form the stationary waves of ultrasonic in a liquid, then it serves like diffraction grating. It is also called acoustic grating. So in the light we will use the word diffraction grating, but if we are dealing with sound like longitudinal properties of any wave, then they are called acoustic grating. Last property, they produce intense heating effect when they pass to the substance because they have more energy. So because they have more energy, they can easily produce the heating effect when they pass through a substance. They are similar to the infrared rays because they are also very high frequency waves. They also produce the heating effect. They are not very high frequency as compared to the visible range, they are less, but they produce the heating effect compared to the ultrasonic waves. So we can if in the layman language we want to compare ultrasonic waves, then we can compare with the infrared rays, except the nature. Nature of ultrasonic waves is longitudinal, but the infrared waves nature is transverse in nature. Next, what are the production method of ultrasonic waves? There are two methods from which we can produce the ultrasonic waves. First one is magnetostriction generator or oscillator. Second one is inverse piezoelectric generator or oscillator. So ultrasonic waves can easily produce with the help of magnet or with the electric wire, depending upon the requirement, depending upon what type of ultrasonic waves, how much frequency we need. So we can produce according to that. First we will discuss what is magnetostriction generator or oscillator in detail. So what is the basic principle behind the magnetostriction generator? It is based upon the magnetostriction effect. So what is this effect? When a ferromagnetic rod like iron or nickel, it is placed in the magnetic field that is parallel to its length, then the rod experiences a small change in its length. This is called magnetostriction effect. So the rod should be ferromagnetic in nature. they like the rod like iron or nickel. If they are placed in the magnetic field which is parallel to the length, then the rod experiences a small change in its length will change. So this is called magnetostriction effect. Because of magnet its length is changing, so this is called magnetostriction effect. So this one is pictorially we can define, like these are the field north and south, electric magnetic field. So this rod is placed parallel to this field, so small change in length depending upon the field, this is because of magnetostriction effect. The change in length increase or decrease produced in the rod, it depends upon the strength of magnetic field, nature of materials, and it is independent of the direction of magnetic field applied. So this one is experimental arrangement for this magnetostriction oscillator. So this is XY is rod which is made of nickel or iron, which is producing ultrasonic waves and it is ferromagnetic in nature. So within this we are inducting a inductor with length L1, its inductance is L1. It is a variable capacitor C. This one is transistor and whose emitter is earth, and in the base region we have second coil with inductance L2. So this M is emitter and this is high tension battery. So how it works? XY is a rod of ferromagnetic material, we already discussed, like iron or nickel. The rod is clamped in the middle. The alternating magnetic field, it is generated by electronic oscillator. This oscillator is electronic oscillator. The coil L1 bound on the right side of the right hand portion of the rod along with the variable capacitor C. This form the resonant circuit of the collected tuned oscillator. So the frequency oscillator is controlled by a variable capacitor. So depending upon what type of frequency we want, so C can be changed because it is variable, and frequency is inversely proportional to the square root of capacitance. Nu is equal to 1 upon 2 pi square root of LC. The coil L2 bound on the left hand portion here of the rod is connected to the base circuit, base of this transmitter. The coil L2 acts feedback loop. So when high tension battery, how it works? When high tension battery is switched on, the collector circuit oscillate with the frequency f is equal to 1 upon 2 pi square root of L1C. Here C is variable capacitor, so we can change the capacitance depending upon the frequency we want, in which range we want. F is equal to 1 upon 2 pi L1C. L1 is fixed because of coil. This alternating current, because of high tension battery flowing through the coil L1, it produces an alternating magnetic field along the length of the rod, and the result is that rod start vibrating due to magnetostrictive effect. So next, the frequency of vibration of the rod, it is given by 1 by 2L y upon rho, where L is the length of the rod. So this is the vibration of the rod. Previous one is the vibration of the oscillator. Y is Young modulus of the rod material and rho is the density of rod material. So it all in all depends upon the what type of material we are using for making the rod of ferromagnetic material. So frequency N is equal to 1 upon 2L y upon rho So the capacitor C is adjusted such that these two frequencies are equal, this frequency and the previous frequency this. So F is equal to N, so that means the resonance takes place. Now I will read these two lines to repeat. So the capacitor C is adjusted so that the frequency of the oscillator circuit, it is equal to the natural frequency of the rod, and thus the resonance takes place. Now the rod vibrate longitudinally with maximum amplitude and generate ultrasonic waves of high frequency from its ends. So this is the complete magnetostriction effect, in which we are taking two frequencies. One is the frequency of the oscillatory circuit and another one is the frequency of rod. When these two are equal, then resonance takes place, and at that time the rod vibrate with maximum amplitude and it will generate ultrasonic waves with high frequency. So the advantage of magnetostriction effect, magnetostriction oscillator, is the design of this oscillator is very simple and its production cost is low. At low ultrasonic frequencies, the large power output can be produced without the risk of damage of oscillatory circuit. Disadvantage of this method is that it has low upper frequency limit and cannot generate ultrasonic waves above the 3 megahertz, and the frequency of oscillation, it depends upon the temperature. There will be losses of energy due to hysteresis and eddy current. So these are advantages and two advantages of this method. Next we will discuss the second method, the piezoelectric generator or oscillator, which is based upon the inverse piezoelectric effect. So like in the previous method, magnetostriction, we are using magnetic field. Here we are using electric field. If the mechanical pressure is applied to one pair of opposite faces of certain crystal like quartz, equal and opposite electric charges appear across its other faces. This is called piezoelectric effect. The converse of this piezoelectric effect is also true. If we apply a electric field to one pair of the faces, the corresponding change in the dimension of other pair of faces of the crystal, they are produced, and this is called inverse piezoelectric effect or electrostriction effect. So the circuit diagram for this electrostriction effect, like this is the crystal plate, in between these two plates A and B, this is the transformer, this is one coil L3, this is another L2 and L1, this is variable capacitor. So this one is oscillator for us. So like before, here this is also this is connected to the collector, and this oscillator circuit is connected to the base, and the ammeter is the earth. So this is simply a key, this is high tension battery. So we will give the electric field here. So depending upon electric field, this will start vibrating and it will change its length or increase or decrease its length. So this is called electric oscillator, piezoelectric oscillator, and it is based upon inverse piezoelectric effect. So the circuit this is a circuit diagram. So these are different instrument used here. The quartz crystal, it is placed between two metal plates A and B. This is quartz crystal. The plates are connected to the primary, this primary coil L3, these two are secondary coils, and which is inductively coupled to the electronic oscillator. The electronic oscillator circuit is a base tuned oscillator circuit. The coil L1 and L2 of the oscillator circuit, they are taken from the secondary of the transformer T. So, these two are secondary coils. The collector coil L2 is inductively coupled to the base coil L1. The coil L1 and variable capacitor C1, they form the tank circuit of the oscillator. So, like we did, these two frequencies should be equal. Here the same thing should be there. So, when a high tension battery is switched on, the oscillator produce high frequency alternating voltage with the frequency f is equal to 1 upon 2 pi L1 C1, where L1 is the inductance of the coil, C1 is the variable capacitor. Due to transformer action, an oscillatory EMF is induced in the coil L3. This high frequency alternating voltage, they are fed on the plates A and B. The inverse piezoelectric effect takes place. So, the crystal contract and expand alternatively. This produces mechanical waves which is called ultrasonic waves. The frequency of vibration of the rod, it is given by P upon 2L Y upon rho, where P is 1, 2, 3, 4 etc. for the fundamental, for the first overtone, for the second overtone etc. And Y is Young modulus of the crystal, and rho is density of the crystal, which is the quartz crystal which we are using here. So, N is equal to P upon 2L Y upon rho. So, variable condenser C1 is adjusted such that the frequency of applied AC voltage is equal to the natural frequency of the quartz crystal, and thus the resonance takes place. The vibrating crystal produces longitudinal ultrasonic waves of large amplitude. So, the basic concept behind this is, if the resonance takes place, then they will produce any type of waves. So, the advantage of this method is that the ultrasonic frequencies as high as up to the order of 10 raised power 8, they can be produced with this arrangement. The output of the oscillator is very high and it is not affected by temperature and humidity like the previous method. It is affected by temperature, and disadvantage is for this method is that the cost of piezoelectric quartz is very high. The cutting and the shaping of quartz crystal are very complex. So, these two methods, they are used to produce the ultrasonic waves. First one is magnetostriction and second one is electrostriction. First method is based upon the magnetic field. With the help of magnetic field, we can vibrate the crystal, vibrate the rod. But in the second method, we are using rod which is based upon inverse piezoelectric effect. So, in the second method, we are applying electric field. So, with the help of electric field, they will produce EMF. So, with the EMF, the crystal will start vibrate and it will produce ultrasonic waves. So, now we will come the last topic of this lecture, that is application of ultrasonic waves in engineering, in medical etc. In all the fields we will discuss. So, first one is detection of flaws in materials, in metals. It is called NDT, non-destructive testing. So, ultrasonic waves, they are used to detect the presence of flaws or defects in the form of cracks, blowholes, porosity etc. in the internal structure of the material, because ultrasonic waves, they can easily reflect, and absorb. So, depending upon that property, we can easily see what is the main flaw in the metal. By sending out ultrasonic beam and by measuring the time interval of the reflected beam, flow in the metal block can be determined. How we can easily detect the flow in any metal or any defect in the metal. So this is experimental setup. It